Hello, everyone. Hello, students. Welcome to my channel. So today I have selected a topic which is very, very important for the students of third year engineering who are developing or going for project as well as for the fourth year main projects. So usually they find difficult or they how to gather the knowledge, how to start or where to finish. So I've developed this video, or I will be telling in this video how to go from beginning to end. So electronic project roadmap from topic selection to final submission is the topic name what we are discussing today. So I will just one by one, I will explain you the things and all. So here, if you are electrical students, you know that the project is very most exciting and sometimes most stressful also. Part of our curriculum, whenever it's micro project, that is in the beginning, the first one, in the second year, usually in India, for your labs, a mini project for your semesters, or the big major project that it defines your final year, because you have to write about the final year project. Sometimes you have to write about the mini project, what you have done in your curriculum or in your college, in your semester, in your CVs for your jobs. So it is very important. So this is one common goal, that is moving from theoretical diagram to working prototype that actually solves a problem. In this video, in this particular video, I'm going to take you behind the scene. We aren't just looking at circuits, we're looking at the professional engineering workflow. From how to choose a topic that gets high marks to building, coding, and finally creating a documentation, which is very important. Documentations are very important. Report that will be impress any external examiner. Let's start building the real thing. Okay, so I will just tell you about this slide will tell you what exactly you are looking for. So here I have divided, as you can see on the bottom side, the project type I have divided micro, mini, and major project. So all these depend upon the complexity of the project. That is, in micro, the complexity is low, whereas in mini it is medium and major it is high. So key focus areas, like when we talk about micro project, is a single logic gate function or timer function or operational amplifier. You can make small circuits and you can show. I will give you an idea about that just after this slide. Then mini is sensor actuator. That is, you use some microcontroller board, basically, like Arduino basic sensors and all you use for that. In major, it is high grade, that is, the complexity is high. So system integration, IoT, artificial intelligence. So you have to use a board like higher standard, that is ESP32, Raspberry Pi, or you have to develop, sometimes you have to develop a PCB also for your circuit. So here I have just given you the idea. First, you have to making it on a breadboard. This is a very simple one. That is, we call this a micro project, right? Very basic component we have used here. So this is a micro project. So there is a confusion how the things will be there, like how to submit and all. Then here you can see in the corner above here on the top, this is mini project, and I have taken a major project, that is ESP32 IoT home automation over here, right? So I will just tell you, I will show you rather. So this is my small PCB on which I have kept a operational amplifier, one LDR, and I have made a circuit over here. Okay. So this small circuit with a few components, and the output will be seen only on the LED. So these type of project, we call it as a micro project. So less component, mostly we do it on the breadboard. Okay. Now, second, I will just show you just to be a little beside this. You can see here. All right. So this is actually basically this is ESP32. You can use some other board also, like Arduino board, and one sensor is there. Okay. This is the sensor. This is the sensor. So this sensor, this board, that is a microcontroller board, it will drive this two servo motors. I kept two servo motors over here. These are the two servo motors. Okay. So this category, which is made on the little bigger board, this is your mini project. Or more sensors, you can add one more sensor on the top of this. I can add this sensor. I can add this sensor also. So this becomes a mini project. That is, number of sensors are 2 or 3. So this becomes a mini project. Okay. So this is micro project. mini project, I will show you about the major project part. So this is major project where I have used a Raspberry Pi Pico board, a display, a Bluetooth device, and some other parts also. Of course, I can add some more things also here. Like suppose I want to add a this is the part, that is this part. I will tell you what is this part. So this is a LoRa, right? This is a LoRa module for LoRa communication, transmission and receiving. I can use it. So IoT based with the display, more number of sensor I can add. Of course, I can add more sensors over here also. I can add more sensors over here. So this type of project, we call it a main project, IoT based mainly, right? So I hope you got the idea. What is the difference between mini project, micro project, and main project that I wanted to show you in a real time. Just now, you must have got a little idea that how you will categorize it in a different this thing, that is micro, mini, main project. So I will just tell you in 6 clear phase for project blueprint, right? So phase 1, starting with the phase 1, topic selection. Okay, so topic selection is the first phase. The mini, major, or anything if you want. In mini also you will select a topic, and major also you will select. Usually the topics are, many of the colleges will tell you to select it by yourself, or some of the college they will ask, or your lecturers, guide, HODs will give you the topics, right? Please don't worry, no hassles, nothing to worry, because there are so many things today to help you out. Okay, only you have to follow the procedure, like what I'm telling you, the phase wise. You have to remember that. Okay, so topic selection is first. Micro project focuses on a single function. Just now I've shown you single function digital thermometer example I'm just giving you, or a simple burglar alarm. Simple components, electronic component, basic electronic components, IC transistor, like operational amplifier, timer ICs, or audio amplifiers, or the related functions, logic gates. If you are making some project, that comes under a micro project. Next comes the mini project, which is for your third year. It combines mainly 2-3 modules, right? That means 2-3 topics. You have to combine it together. Like something should be displayed on the display, as well as my motor should move, right? So there are 2 things here. Okay, so you have to combine it in that such a way. All right, like example is automated irrigation. How irrigation, when the soil moisture level goes up and down, then only the motor starts. There are 2 things over here. You can add temperature also, temperature of the soil, temperature of the water. So what you have to do, you will add 1 more or 1 or 2 more modules or sensors. So system using moisture sensor and water pump. 2 things are here. So this is mini project. Now we come to the major project. Integrated systems with the data logging, that is IoT, or specialized hardware. Specialized hardware means what? Mainly communication. I just now shown you a LoRa module. So if you want to do project with the LoRa module, if you want to do project with the Bluetooth module, if you want to do project with the RF module, so there are different things or different modules available with it in the market where you can do the project. See that it should be IoT based, little IoT based and advanced. Okay, so like example, it is given solar tracking system, power system, cloud computing. Please remember, when we talk about IoT, at that time you have to be very careful that it has to be connected to the cloud. So cloud can be HTTP cloud, it can be ThinkSpeak cloud, it can be Blink hardware, or there are so many other things where you can MQTT, HTTP, everything you can use it, but it should be in a real time. And one more thing I will tell you, when you do a major project, please see that it is done on a PCB. That means the soldering has to be done on the PCB. One golden rule, pick a project that solves the real world problem. So these are the things which you have to remember in the phase 1. Now come to the phase 2, the paper first design, right? First to the paper first design. So what you have to do that in the next stage, second stage, draw block diagram. Here I have shown you the block diagram. You can see here on the bottom side, I have given you the blocks. So here we have used 1, 2, 3, 4, 3 or 4 blocks. So this is nothing but we call it as a block diagram. Once you have the schematic diagram, once you understood the diagram, the concept, how my circuit is working, very easily you can make block diagram. So first thing, block diagram, identify the input, that is the sensors, processor like microcontroller, like Arduino, ESP32. If you are doing project with ESP32, then you have to connect the ESP32 and output LCD motor or relay. So this is output. So input, microcontroller, and output. So when you have to make 3 blocks, if this is the case, then you have to make 3 blocks that you understand. When you understand the schematic and the concept, you can easily make it. So first is block diagram. Second is verify component compatibility. That is, check if the sensor's operating voltage is 5 volt or 3.3 volts. We do a lot of mistake. We spoil our components. Why we spoil it? Because you give higher voltage, you get either you go give lower voltage or you give higher voltage. So you have to be very, very careful, especially I2C based sensor will work with 3.3 volts. Maximum sensor, the new sensor which are coming in the market works on 3.3, don't provide 5 volt to it. So you have to be very, very careful with the sensor. And how to match with the microcontroller, that also you have to see. Okay. Third point is circuit simulation. Now, how you will make simulation? There are different type of simulation online software like Tinkercad, Multisim, Proteus. As I have shown you here, this is the schematic, this is the circuit diagram, this is the block diagram, and this is simulation diagram. Sometimes simulation is required, sometimes simulation is not required. So whenever your guide, your lecturer asks for it, please do it. So there are different tools. Like I will suggest you WalkV also, IoT, if you are using ESP32 or latest STM32 microcontrollers, then go for a WalkV software. So this is the phase 2. Now let's go to the part 3, that is the phase 3, hardware acquisition and breadboarding. That means first you have to make it on the breadboard for testing purpose, then only you can go to the final setting either on the PCB or on the breadboard itself. So here the real work is beginning, okay, right? So the BOM, that is bill of material, how to make a list of very bill of material, what are the parts required. See, please remember, you require very accurately, you should make a complete this thing, that is what is required for you. So bill of material is very, very important. Suppose you're going to market, if you miss a component, then again you have to run back to the market. So I've just shown it here. This is the example of bill of material. You will make how many numbers, what quantity. Please remember, current rating, voltage rating, you tentatively, we don't look into it, but please remember when there's somebody asks you to bring a transformer. So current rating is important, voltage rating is important. So resistor, quarter watt resistor, half watt resistor, 1 watt resistor. So whatever it is required for your circuit, you please bring those components carefully. That is why bill of material is important. You have to make it, write it down on the paper and bring. Now, second part is the breadboard prototyping. Emphasize that it must build the circuit on a breadboard. Please remember, first you have to make it on the breadboard first. It doesn't work there. Here, it will not work on the PCB. If it works here, then only you can transfer your components properly on the PCB. So that's why breadboards are important. Please remember, some of the colleges, some of this thing that is micro and mini projects, they ask to give it to you on the breadboard itself. But please remember, breadboard are temporary, where the PCBs, this type of PCBs are permanent. Why? Because you sold the component there. Anyhow, so incremental testing, that is, don't build the whole thing at once. Stage wise, you have to make it stage wise. First power supply stage, then another stage, then another stage. Likewise, you go it. So it will be easy. Don't spread out the whole thing together. Right? So that is the meaning. Component, one golden rule here, component selection. You don't just buy what cheapest, you buy what is compatible. Don't go for the cheap things, don't go for the alternatives. Compatibility is very, very important. So I hope the third phase you understood very. Now we come to the fourth phase, coding and firmware. Here a lot of things is to be done, that is coding part. Suppose you are using a microcontroller, then the coding part is very important. Mainly, we do it with the 2 or 3 coding language, that is Python, C++, and Java. For many students, this is the hurdle actually. flow chart, drawing a logic chart before writing a single line code. Please remember, nowadays nobody writes code, but if you are very particular about writing the code, if your colleagues tell you to write the code by yourself, so please follow the chart. Okay, line coding, syntax and everything, you please remember particularly. So there is something called modular coding. Write a small function for each task. Debugging, how to use this serial monitor to see what the microcontroller is thinking. Serial monitor is given in a IDE for to check to get the output. So what are the coding for softwares what we use? If you are using C++, if you are using Arduino board, then Arduino IDE is the best. If you are using ESP32, you can go for Arduino IDE itself because it works on C++. And if it is MicroPython or Python, so I would suggest go for Thorny IDE. Very simple, but that there you can program only in MicroPython. So these things you have to remember. Okay, so IDEs are very, very important for writing the firmware and the codes. Okay, right. So next is fifth point, that is phase 5, final construction PCB. And what is the zero PCB? Okay, zero we call it. So zero PCB or PCB, and I will just tell you what is actually this thing. There are two types of PCB. One is called a general purpose PCB and one is designed PCB. Suppose your design, this is for the final year students, especially for the major this thing. You please learn PCB design for designing a PCB. That is according to your circuit, what is required by your circuit, the tracks and the placement of the components are particularly made on the PCB. That is called as the real PCB. Zero PCB, or we call it as a simple PCB, will have perforated holes. Like I will just tell you. So this is the PCB that is made for this particular circuit. Okay, this PCB is made for this particular circuit. Whereas zero PCB will have small holes in there. Okay, it will have small hole. There is no arrangement like thing. You have to put a jumper for connections and all. So that is zero PCB. Okay, so more major projects, college just often expect a custom PCB. Suggest easy tool like Easy EDA. There are so many other tools for making the PCB or learning this thing. You can learn. You can see my videos, the previous videos, the PCB design tools and all. I've taught you in there. You can just follow that also. So the other part is enclosure. Now you have to put it in the enclosure. The whole thing has been made, and you have to. So please select a correct enclosure: plastic, transparent, non-transparent, wood, fashions, house size, so that it should give a good reflection of your project. Right? So these things, enclosure, are very, very important part here. So I hope you understood the phase 6. Now we come to the final phase, that is the phase 6, sorry. Okay, the submission, the document. This is very important point. So what you have to submit, that means what you have to give in your college along with your hardware, that is your project. So first is abstracts and introduction. What is name of your project and what is the work, what is the purpose of that project? These things comes under the abstract. You'll find different type of abstract, and please don't hesitate to take help from AI. Nowadays AI is there. Previously it was not there in my time, but now it is there. You can definitely take the help of the AI. But please remember, AI will only guide you through, but it will not fix your component and it will not give you the output. That you yourself has to do it. Okay, so first point is abstract and introduction. Second is hardware description. That means whatever the parts you have used, whatever the components you have used, you have to describe why you have used it. What is the working voltage? That is data sheet. Refer to the data sheet. I'm not asking you to give the complete data sheet, but refer to the component. What is the working voltage? How much voltage I can give you? What is the supply? What are the GPIO pins? Where your sensor is connected? Why it is connected? That GPIO pin is I2C or serial or some another platform. So all these things you have to write it down on the hardware description. Third is circuit and flowchart. Circuit is important. I've just now given you circuit component is important, and flowchart. Please remember, if you know the connection diagram, that means if you know the GPIO pins and where it is connected, you can make the circuit not a big deal. You have so many software for doing that also. So circuits and flowcharts are important for us. That is the point number 3. Point number 4, result analysis. Please remember, photos of the working project and data graphic collection is important. Photos can make videos also that will impress your guide, your professor, that really it is working and what is the output. And please remember, you can make a PowerPoint presentation, a beautiful PowerPoint presentation, definitely you will get good marks. So all this thing has to come step by step in the result analysis. Okay. Fifth is conclusion, future scope. That is why conclusion means what is the last thing, that is why you have done this project and what is the outcome of this project, and future, that is future you can add something else in this project and what will be the outcome. So all these things you have to put it together and document it in a complete spiral binding book and you present it with this thing. Please remember, Viva is also an important part. So in this phase 6, you have to prepare yourself. That means you have to study deeply about your project and present yourself with the help of your own voice. You make a video and present it, or you make a PPT and present it. That will definitely fetch you a good mark. Please remember, finally, I'm telling you one more thing. Since I am from the industry background, I would like the students to work in my company who have hands-on experience and done a good project in their academics. That is mini project as well as major projects. I hope this information will give you some ideas. Please remember, I will share some of the links that is which is required for the documentation in the below this video. Please, if you have any comments and this thing, please do write to me. Thanks for watching. See you next time.